Hello, everyone. Welcome back. So today, I want to talk about the double angle formulas. These are a set of formulas that are useful in trigonometry and helping them simplify trigonometric expressions sometimes. So our goal is to understand how the double angle formulas are basically related to the sum of difference formulas. So if you haven't seen my other video on sum of difference formulas, please watch that. And then be able to use the double angle formulas. So first, let's take a look. So the sum of difference formulas are these. So basically, if you start with two angles, A and B, then base these formulas then tell you how you can get the sine, cosine, and tangent of either A plus B or A minus B. And then if you want the other three trig functions, those are the reciprocal trig functions. Just, for example, if you want cosecant of, say, A plus B or A minus B, just do 1 over sine. Now, these formulas, how they work is, notice I have a plus or minus here. So if you're using plus, if you have the top sign here, use the top sign here, which is plus. And if you use the bottom sign here, the minus, use the minus here. Notice they alternate for the cosine and then somewhat for the tangent. So cosine, if we're starting with A plus B, use the top sign here, use the top sign here, which is the minus. So make sure you understand that alternation of the signs with the formulas. For example, also here, if you do tangent of A minus B, then use the minus on top and then the plus on the, to do A minus B, use the minus on top and the plus on the bottom. Okay, first, let's show how I actually can get these what are called the double angle formulas from the sum difference formulas. So let's take a look at that. Hang on, I need to, there we go, get the draw menu. Okay, I want to show then once again how I can get the double angle formulas from the sum and difference formulas. Okay. So first off, use 2a is equal to just a plus a. So if we want to define twice a, of course, that's just a plus a. So the easiest one to start with is actually the sine version. All right. So then we have sine of a plus a. Then from this formula, that's going to be the sine of a times the cosine of a. Then since we're using a plus, the top sign here is the top sign here, plus the cosine of a times the sine of a. Okay. Now, if you notice, remember we can multiply in any order. So the sine of a times the cosine of a is the same as this. And so we have two of these. And so this is just 2 times the sine of a times the cosine of a. And if you notice, let's get rid of that, that is the same thing we see right here. Okay. So then the sine of 2a is equal to that. Now let's look at the cosine. Actually, there are two versions of the cosine, actually 3 versions of the cosine. We'll explain where those come from as well. Okay. Now, so next one, let's do the cosine of a plus a. All right. So from the formula, so it's the cosine of a times cosine of a. And then here, since we're using a plus, the top sign, we use the top sign here, which is a minus, then minus, then the sine of both angles. So the sine of a times the sine of a. Of course, that's obviously then cosine squared of a minus cosine squared, minus sine squared a. Okay, and so that obviously then is the cosine of 2a. Now, where the other formula comes from, the other two versions, okay, so then if we use the Pythagorean identity, the sine squared of a plus the cosine squared of a, just in terms of a, is equal to 1, then we can write the cosine squared here as 1 minus sine squared. The cosine of 2a is going to be 1 minus sine squared a, then minus sine squared a. So once again, all we did here is just replaced cosine squared of a with, we solve this for the cosine of a is 1 minus sine squared a. And obviously this becomes 1 minus 2 sine squared a. That's the second one. Okay. Then also, if we replace sine squared with, so we solve this expression for sine squared, that's 1 minus cosine squared. So we have the cosine of 2a is equal to cosine 2a minus 1 minus cosine squared. So just replacing sine squared with 1 minus cosine squared. And then this becomes, of course, cosine squared a minus 1 plus cosine squared a. And so if we combine those, then this becomes 2 times cosine squared a minus 1. So that's how we get all those three different versions of that. And then finally, let's do tangent. And so tangent of a plus a, okay, just using the formula. So on top, since we start with a plus, we have the top plus is on top, we have a plus here, tangent of a plus the tangent of a. Then down here, since we have the top sign here is a plus, we use the top sign here, which is a minus, then 1 minus the tangent of a times the tangent of a. And then just simplify those. So you have 2 tangent of a's up here, so 2 times the tangent of a. Down here, then this is 1 minus the tangent squared of a. And this is the formula for tangent 2a. Okay, so that's where one way at least you can get the double angle formulas is directly from the sum and difference formulas. Okay. It just shows where they come from and also how they're related to the sum and difference formulas. Let's say the only way you can get those. Okay, and then let's just practice with a few examples working with this. So our directions will be to simplify. So the first one, number 1, let's say we have this expression. So 2 times the tangent of 15 degrees over 1 minus tangent squared 15 degrees. Okay. And also I should go back and relate. So what the double angle formulas do for us is if we know the single angle, if we know the values of the trig functions for a itself, then we can easily find the values of the trig functions for twice that angle. Okay, in the same way we did for the sum of two angles and sum of difference formulas, we can do the same thing. We can find twice whatever angle A is using these formulas. And also we can find reciprocal identities by taking the reciprocal of each one of these. So now let's take a look. So how do we, of course, what we want to do then is compare this expression to the expressions we have. Okay, which one matches the most closely? Obviously, it matches this one the most closely. Okay, so here, if you notice that A is equal to 15 degrees, and we don't know, at least don't have a good exact value for that, for A of 15 degrees, but we do for 2A. Okay, if A is that, so 2A is just 2 times 15 degrees versus 30 degrees. Okay, now if we compare this expression directly to this, then so the tangent of 2 times 15 degrees is equal to this tangent of 2 times tangent of 15 times 1 minus tangent squared of 15 degrees. Okay, and so this then is equal to the tangent of 30 degrees. Okay, now the tangent of 30 degrees just a moment, check something. and the tangent of 30 degrees, you can get that from, for example, like a unit circle or reference angle or a special triangle. But of course, the tangent of 30 is equal to the sine of 30 over the cosine of 30. And if you use a unit circle or reference or special triangle, then the sine of 30 is 1/2. Then the cosine of 30 is the square root of 3 over 2. Then multiply by the reciprocal of the denominator. 1/2 times 2 over the square root of 3. 2's cancel out. And this is going to be 1 over the square root of 3. And then it's also, if you want to rationalize that, you can, if you need to. Multiply the top and bottom by the square root of 3. Make a better 3. It's almost like a 5. Okay, and then that's going to be then square root of 3 over 3. So this is then the tangent of 30 degrees. Okay, so in this case, what we did is we didn't know a good exact expression for the tangent of 15 degrees, but since we had this expression here, then I was able to find that for the tangent of 30 degrees. Okay, look at the next one. Number 2, let's say I have this. All right, so I have cosine squared of pi over 8 minus 1/2. Okay. Once again, let's look at our double angle formulas. So the question is, which one is this the closest to? What look the most like? All right. So we'll look for one that has a cosine squared, and obviously this one, 2 with cosine squared. This one, this does not have a sine squared. So the closest one to this one is this expression right here. It looks the most like this, but it's not exactly like that, and we'll talk about that. Okay, so what I'm going to say then is this looks like cosine of 2a is equal to 2 times the cosine squared of a minus 1. Okay, it's the closest to that, but you notice it's not exactly the same. Okay, here we're missing a 2 out front. All right, and this also, you notice, is divided by 1/2. But we can actually make that happen. All right, if we divide both sides by 2. All right, and so that's going to give me then cosine of 2a over 2 is equal to, if I divide both sides of this by 2, 2 times the cosine of a, cosine squared of a rather, minus 1 over 2, and we can split this up into 2 fractions. If we do that, then we just get the cosine of 2a. I'm having trouble writing today. Let me do a better job here. Here we go. So the cosine of 2a over 2 is equal to, divide, let's do that over here, split this up into 2. So we have 2 times the cosine of 2, cosine squared of a over 2 minus 1/2. And of course, that's just going to be cosine squared of a minus 1/2. Okay, now this now looks like the same. So now if we compare it, then obviously then a is pi over 8. And so what that means then is that 2a is just twice that. So 2 times pi over 8. And that then would be 2 pi over 8, which would be pi over 4. Okay. And then finally, we can say is our original expression. Cosine squared pi over 8 minus 1/2 is equal to the cosine of twice that, cosine of 2 times pi over 8 over 2, which is the cosine of pi over 4 over 2. Okay, so now we just need to find the cosine of pi over 4. And once again, if you use a unit circle or a special triangle, that then is equal to the square root of 2 over 2 divided by 2. And of course, once again, multiply by the reciprocal of this. So the square root of 2 over 2 times 1/2. And finally, this just becomes the square root of 2 over 4. So that's the exact value. When we don't have a good exact value for the trig function of the square root of pi over 8, we do pi over 4. Okay. All right. And let's take a look at one more example. So give me just a moment. Okay. So let's go down here and let's look at our next example. What we're going to do, this actually means something a bit different. So what I'm going to do then is find sine of 2 theta and also cosine of 2 theta. Or if we know that the sine of theta is equal to 2/5 and cosine of theta, not 2 theta, but cosine of theta, these both sines of theta, cosine of theta here, is less than 0. Okay, so what we're going to do is use our knowledge of this angle theta to find this. Now, where can we start? Well, first off, let's figure out what we know about this angle theta itself. Okay, we know it's sine. We know two things, or actually three things. We know it's sine, the value of sine, but also what sign plus or minus it has, and also the sign of cosine. So now cosine is less than 0. Okay, whereas cosine less than 0? Well, that's in quadrants 2 and 3, and then sine of theta is greater than 0 in this case in quadrants 1 and 2. Okay, so which one do they have in common? Well, obviously it's quadrant 2, so we can say angle theta is in quadrant 2. What does that do for us? Well, let's draw an angle. Draw a picture. Okay, we're in quadrant 2. We know sine is 2/5. Remember, sine in terms of x, y, and r is y over r. Now we can make a triangle. Okay, so this is our angle theta. And we make a triangle, and sine is 2 over 2 is y over r. So this is 2. This is 5, and of course we have some x here. Okay. Then we just need to use Pythagorean theorem to find x. So we have x squared plus 2 squared is equal to 5 squared. And just figure this out. So plus 4 is equal to 25. And then we'd have x squared is equal to 21. And so x is equal to plus or minus the square root of 21. Okay. And once again, since in quadrant 2, x is negative, so x is equal to negative square root of 21. Okay. All right. So now what we know about this then, all right, we're given that the sine of theta is equal to 2/5. And now I know that the cosine of theta is equal to negative square root of 21 over 5. It's x over r. Okay. So now we know the values of sine and cosine. So now we can find the sine and cosine of 2 theta. Okay. So probably the best one to start with, I'll just say, so the sine of 2 theta, okay, is going to be 2 times the sine of theta times the cosine of theta. That's our formula. And so that's going to be 2 times 2/5 times cosine, which is negative square root of 21 over 5. And so this is not really going to come out nicely. Nothing is really going to reduce. It's going to be negative. Then 2 times 2 is 4 times the square root of 21 over 5 times 5, which is 25. And that is the value, the exact value of sine of 2 theta. Okay. Then cosine of 2 theta. And here we can choose any one of these we want. Okay. Then let's pick the first one. We can also choose any of them. That's up to you. So actually, we could have actually found, in fact, let's do it this way. Since I was given sine of 2 theta, I could actually have done that one first without even finding what cosine of 2 theta was. So that would be 1 minus 2 times sine squared of theta. And that's probably actually the easiest one to do. All right. And so this is 1 minus 2 times 2/5 squared. And actually, I'm about to run out of space. Let me just finish this off here. So 1 minus 2 times 4/25. And so that's going to be equal to 1 minus 8/25. And now make 1 is 25 over 25. So we have a common denominator. And so finally, that cosine value, the cosine of 2 theta, is going to be 25 minus 8, or 17/25. Okay. And also in this case, we want to find tangent. We won't take the time to do it. You plug it in the formula. Now we're not given the tangent. We can also find tangent from, sine and cosine. So tangent is sine over cosine here, theta. Then we can also simply find tangent of 2 theta by just dividing sine of 2 theta by cosine of 2 theta. Okay. So what we learned here today is just how to use some more practice, how to use the double angle formulas, where they come from. One way to get them is from the sum of difference formulas, then also use then the double angle formulas for working with angles. When we know the trig functions of the angle A, then we can easily find the exact values of trig functions for the angle 2A. Thank you. Have a good day.